what we're talking about here is that the ratios are different if we're talking about lengths or areas or volume. Our concept is that the length ratio is some scale factor, A over B, and the area ratio will be the square of those, A squared over B squared, and the volume ratio will be the cube of those. So here I'm starting with seeing that they're giving us a circumference, and they're telling us that it's 12, and this one's 12 pi and 2 pi. So I know that that's a length ratio because it's a circumference, which is measured as a length. It's inches or centimeters or meters. And then I can reduce this to get 6 over 1. If yours is 1 over 6, is that okay? Sure. Just keep track of which way it is. Once you get one of them done, your area ratio would be the square of that. So 6 squared over 1 squared is 36 over 1. And your volume ratio would be that cubed, or 216 over 1. This is the first step, filling in this box for the length ratio, the area ratio, and the volume ratio. The second step is to see what the question's asking for. In this case, it's asking for the ratio of two areas. So should I use LR, AR, or VR? AR. Answer is simply 36 over 1. And again, that doesn't really stretch our brains. Question?
Whatever 36 will also be correct, right?
Yours is actually right. Why is mine wrong? Because I said circle, or the question was circle P over circle O. P is the bigger one. O is the little one. No, mine's right. Right? So you got to look at the picture. It asks for P over O. So that fraction would be big over small. So 36 over 1 is the right answer. Well, let's do a little more application of this. Take a look at number 3. It's telling us that the ratio of A to B is 5 to 2. What do I then put into this box based on that? 5 over 2 for LR, which means AR would be what? Good, 25 over 4, and VR, 125 over 8. But the whole point of this is to do something with it after this. Once we get this box, the question is, what are we trying to solve? In this case, we're trying to solve the volume. So which ratio should I use? The length ratio, the area ratio, or the volume ratio? The volume ratio, of course. So I'm going to say 125 over 8 equals some proportion, some fraction. This tells me the volume of the large prism is 250. Should that go on top or bottom of this fraction? Sorry, couldn't hear. On top. Why? Because this number is bigger than this one. So we want this to be bigger than this one. And again, you might be able to just see this. What do you have to do to 125 to get to 250? To make it an equivalent fraction, you just need to double it, right? Which means if you doubled 8, you'd expect to get 16. And you can formalize this by doing the multiplication, the cross multiplication. When you divide, sure enough, you'll get x equals 16. Let's take a look at number 4. It's similar with a little twist. The right cylinders are similar. Little r is 10. The volume of the large is 64. The volume of the small is 8. Find the radius of the large. How do I begin? Got to fill in the box here. They gave us one ratio that matches 8 and 64. Where do I put that? Area? Volume, right? These were volumes. So I'm going to put them in as the volume ratio, 64 over 8. And I could use those ratios as is, but I'm going to reduce it. I can divide both the top and bottom by 8. So this becomes 8 over 1. If the volume ratio, which is supposed to be A cubed over B cubed, is 8/1, what's the length ratio? Good. I'd be taking the cube root of 8, dividing it by the cube root of 1, and I'd end up with 2/1. If I squared that, I'd get the area ratio of 4/1. And if I cubed it, it would bring me back to 8/1. Once I get this box filled in, my question is, what am I trying to solve? What does this capital R represent? Radius, right, of the big cylinder. Is that a length, area, or a volume measurement? Length. This is an LR situation. So I'm just going to say 2/1 equals, got a value of 10. Does that belong on top or on the bottom? Why? You're right. Because it's smaller. We expect this figure's information to be smaller than what we're looking for, the radius of this one. And then I can cross multiply to solve. R is equal to 20. Five, this seems intuitive and easy. I've got this. 3, it's an algorithm, a process I got to go through, but I think I'm getting the familiarity with it necessary to succeed. 1, why can't I just use 2/1 for any of those? Good. Hands down. Please try number 6 yourselves. All right, before I go over this, let me see how you feel about it. 5, I think I'm solid. I think I did it correctly. I feel good. 3, I'm on the right track. I could use a few more minutes just working on it, but I'll get it. 1, I'm missing something. Something didn't work out for me. By the way, your answer should be 6. Okay, so let's do this step by step. What's first step? Plug it in. That gives me something. Somewhere in here are 2 corresponding values. They could be 2 length values. They could be 2 area values. They could be 2 volume values. I see 64 gallons. Is that a length, area, or volume? I see 1.5 feet squared. Is that a length, area, or volume? And I see 8 gallons. So that's another volume. So 2 of these are volumes. So I'm going to go with a volume ratio, 64 to 8. And although I could use that, right, the cube root of 64 would be 4, cube root of 8 would be 2. I could put 4/2. My life becomes dramatically easier if I reduce it first. Now, if that's 8/1, then this ratio would be the cube root of 8 over the cube root of 1. You guys know how to do a cube root on a calculator? Would you like to know that? You could do it on any calculator by doing 8, using the little up caret key, open parentheses, and say 1 divided by 3. In other words, raise it to the 1/3 power. And that makes it a cube root. If you raise it to the 1/2 power, that would be the same as the square root. If you raise it to the 1/5 power, that would be the same as the 5th root. In this case, you're asking what times itself 3 times makes 8. We can do that in our head. It's 2/1. And then the area ratio would be that squared. So 4/1. We've used up 64 gallons and 8 gallons. The only number left for us is 1.5 feet squared, the area of the cover, and it wants us to find that. So is that a length, area, or volume ratio? Area, because it's feet squared. So I'm going to use this ratio, 4/1. And then we've got 1.5, which fits on the smaller tank. So is that going to go below or above? 1.5, because 1's smaller than 4, and we're looking for x. Cross multiply to solve, we get x is equal to 6. And we'd use the same units, feet squared. Any questions on using the similarity ratios, scale factors, to find areas or volumes of similar figures? Yeah. I took the volume ratio and recognize that from the beginning here, the volume ratio is always the length ratio cubed to the third power. So I took the 8 on top and did the cube root of it by doing this on the calculator to the 1/3. That gives me a 2. Okay. Any other questions? Alrighty. For the second part of class, I want to do something that I hope is a little bit fun. And as you know, we were supposed to have a test today, right? And I canceled the test largely because this piece of information was missing, but I also noticed that people were still working on the review packet. So I want to give you a little more time on that. There's also some people that haven't yet finished the test from the last unit. So to allow for all that, I pushed the test. But there's also a lot of you who are good. You're like ready to test today, and so you need something to do today. So I want to share a story with you. I bought a house 10 years ago now in Corte Madera, and it's small, right? When I bought it, I had a 1-year-old and a 3-year-old. And it was okay for our needs then because the 1-year-old wasn't using a toilet, but it only has 1 toilet, 1 bathroom. So now that I've got a 13-year-old and an 11-year-old, it's really small. But I could have predicted that. In fact, I did predict it. So for the last 5 years, I've been engaged in a process to try to expand my home. That means getting permits. That means getting an architect. So what you can see here is a drawing of my current home. I live entirely on the top floor. The bottom is just like an old garage, 1926 home. So the garage is really too small for a car. It's a good storage room, and that's about it. But I chose this home because it's got an open plot of land right here. It's got a second lot that's open. So my plans are to take this wall and push it out 18 feet. Changing the roof line, of course. Bunch more living space up here. I'm going to have a nice deck out here. Mount Tam is over here, so I'll be looking at Mount Tam from that deck. And as long as I'm building all this on the top floor to live on, I'm going to build out the bottom floor as a little rental unit, right? A separate 1-bedroom, 1-bath unit. Make a little money to pay off the expenses. So what I've been doing is trying to go through this process to solve this thing, to get the permits done. And I want to share with you a little bit about what you have to struggle with. Again, on the bottom, I'm building a little 1-bedroom. Is that it? Sorry, it's a 26-page document designed by an engineer. So there's a little bit of detail in here. There. So on the downstairs, this is the little rental unit. It's small. You come in the door here. There's a living space for you right here. There's a kitchen. Any guesses what this symbol means? Well, yeah, refrigerator. What about this symbol? Stove or oven. And this one? Yep. And then you go, and these are all cabinets or counters. And what you'd expect is that this depth is 24 inches. That's pretty standard. You can have a stove that's 30 inches, or you can get a bigger one that's 36 inches, etc. These are all very specific measurements. You guys are working in similarity, which is where 2 similar shapes have a scale factor. That's exactly what this is. In real life, this is 30 inches. The engineer draftsman had to produce this in such a way that it's to scale, so that it matches in comparison to the length of this run, to the distance that it goes to this wall, to the length of the room. All these things have to be in scale so we can see what this looks like. This is a bedroom with a couple little doors going out to the back deck. If it qualifies as a bedroom, it has to have a closet and a window or way that you can exit the room in case there's a fire. This is the bathroom. What is this over here? 2 sinks. It's called a double vanity. And that's just for a little bit more flexibility. You can have 2 sinks, 2 people brushing teeth or whatever. This is the toilet. And of course, the toilet is such a hassle. It doesn't look like it as much on this drawing, but I think there's 2 feet to each side of that. That's what's required so that you can get in there and make the space you need. And in addition, this is a tub. So what I've got for you today is an opportunity for you to build your dream house. I will give you a piece of graph paper, and on that piece of graph paper, you will draw an outline of a 1,000 or more square foot home. You'll build into it like this, a bedroom, a bathroom, and a kitchen. You must have the basic elements here. You must have a refrigerator, a stove, a sink. You must have a shower or bath, a sink, 1 or 2 sinks, toilet, and you must have a bed. I don't have a bed in this one. If you go to Canvas modules, you'll find that I've posted the details of what's expected of you. Just a second, I'm pulling it up now. But the internet is not playing with us. So here's the task. You have to draw it on a piece of graph paper, make it to scale. The requirements are that everything be to scale. Within the kitchen, you need a stove or oven that's 36 inches wide. Refrigerator 36 inches wide. Sink is 36 inches wide. And the counter depth, in other words, if you're standing at the counter, how far till the wall is 24 inches. You need a bathroom with these components. You need a bedroom with one of these 2 beds. Any questions on what you guys are going to do here? Yeah. No, this is today's assignment. It's an opportunity to play with scale factor in a way that's a little bit more authentic. And if you need to make up a test, this is a good time to make up a test because you're here in class and I can proctor you. If you have questions about the review pack, this is a good time to ask those questions. And if you're all set on that, you can just go to town making your thing here.